Unit 5, Lesson 4, Concavity and the Second Derivative Test. In our last lesson, we found intervals on which a function was increasing or decreasing and discovered how the first derivative describes the direction of a function, how the y values are changing. And in this lesson, we will see that the derivative of f prime of x, that is the second derivative, will describe the concavity of the original function f of x. Concavity tells us the direction of the curve, how it bends. Just like direction, concavity of a curve can change too. The points of change are called inflection points. So we're going to explore concavity here. Draw small tangent lines at points along the curve below. What do you notice about the slopes of the tangent lines, which are the derivatives, as you move from left to right at these points? So if I was imagining the slope of my tangent line, 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 if I could see that here they're negative, 0, and then positive, 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 and they start getting higher, increasing. So we know that this is concave up, and we know that our derivative, so our f prime, is increasing. So think about, if they're asking you if something is increasing, then you're going to take the derivative of it. So if I wanted to know if f prime was increasing, then I would find f double prime. And if it's positive, that means we have upward concavity, okay? So now we've got positive, then it goes to 0, then negative, 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 and they're getting steeper, okay? So that means that your f prime is decreasing. And notice that if we took the second derivative, it would be negative here because it's concave down. So, definition of concavity here, let f be differentiable on an open interval. The graph of f is concave upward on I if f prime of x is increasing on the interval I, and concave down on I if f prime of x is decreasing on the interval I. So we're talking about the derivative increasing and decreasing, and you find those intervals by taking the second derivative and looking at the sign in between your critical points. So test for concavity: if the second derivative is greater than 0, then the graph of f is concave up. If the second derivative is less than 0, then the graph of f is concave down. So let's go ahead and look at our first example here. Given f of